Welcome to the Level 1 video on the modulus function. Let's start off by stating the definition of the modulus function. So, the modulus of x, we call it x bar, is defined as follows. The modulus of x is equal to x for x greater than or equal to 0, e.g. the modulus of 5 is 5, and the modulus of x is equal to x for x less than 0, e.g. the modulus of minus 5 is equal to 5. We can go ahead and look at some plot examples. Okay, so first of all, let's plot f of x equals the modulus of x. Okay, so we just have to reflect in the x-axis. So here's where the graph of f of x equals x would normally be. So we just have to reflect up here, and now we're going to plot f of x equals the modulus of x minus 1 squared minus 16. So normally this would be a parabola. This, but we reflect in the x-axis, so it actually looks like this. Then we can plot f of x equals the modulus of x minus 1 cubed minus 16, and this would look something like this. But then we reflect up again in the x-axis, and the fourth and final example, so if we plotted f of x equals the modulus of x minus 1 to the power of 4 minus 20, then again this would be parabola. So this is what the graph would look like without the modulus. But because of the modulus signs, we reflect in the x-axis. Okay, so let's look at some examples that we can actually answer. Sketch the graph of y equals x minus 1 squared minus 16, and from it sketch the graph of y equals the modulus of x minus 1 squared minus 16. Okay, so our solution, if we draw our axes, we know that this is going to be a parabola. Okay, and what exactly are our roots here? We would need to solve x minus 1 squared minus 16 equals 0. And when we do solve this, we get that x is minus 3 and 5. So we know this point is minus 3 and this point is 5. So the sketch of the modulus of this is going to be the same above the x-axis, then mirror with the bit in between the roots, and then be the same again past the root 5. Okay, so let's look at another example. Sketch the graph of y equals sine of x for minus 2 pi is less than or equal to x, which is less than or equal to 2 pi. And from this, sketch the graphs of y equals the modulus of sine of x and y equals sine of the modulus of x. Okay, so let's give our solution to this. Okay, first of all, let's plot sine of x with the period 2 pi. So sine of x will look like this. And now let's go ahead and plot y equals the modulus of sine of x. So everywhere where sine of x wants to be below the x-axis, it will just reflect. And if we plot y equals sine of x but the modulus, then this will only be affected when x is negative. So x positive, it will be the same. And when x is negative, it will just behave as it does when it's positive. So we'll just get a reflection completely in the y-axis. Thanks very much for listening.